Good morning. We continue with the reactions of esters. Next is claisen condensation. Claisen condensation. So, esters containing alpha hydrogen will undergo self-condensation reaction in the presence of strong bases like sodium alkoxide to give beta keto ester. This reaction is known as claisen condensation. So, what is claisen condensation? Esters having alpha hydrogen will undergo self-condensation reaction to give beta keto ester. This reaction is known as claisen condensation, usually in the presence of base like sodium alkoxide. Okay, so look at here. Example: CH3CO OCH3. Okay, this ester is having a, say, this is a CO group attached to carbon. This is alpha carbon. So these hydrogen atoms are alpha hydrogen. So this type of esters having alpha hydrogen will undergo self addition. That means one more molecule. Self addition means two molecules are required. Look at here how I am writing the second molecule. This is first molecule, and CO group attached to carbon, alpha carbon. These hydrogen atoms are alpha hydrogen. So one alpha hydrogen, next molecule CH3 can be written as CH2H. The rest is the same, COOCH3. This is the second molecule, and you can see that here you can see that CH3O, and here it is H. What is eliminating? Methanol. CH3OH will be eliminated, and what we get, this is taking place in the presence of sodium alkoxide, CH3ONA, sodium ethoxide, CH3ONA or sodium ethoxide. Okay, you can take sodium alkoxide, okay, or RONA, alkoxide, sodium alkoxide, and what we will get, CH3OH will be eliminated. The rest is CH3CO, then here it is CH2, and here it is CO, and here it is OCH3, plus what will form, plus CH3OH. Okay. Now this is beta keto ester. What do you mean by beta keto ester? Look at here, this is our ester part, and CO group attached to carbon, this is alpha carbon, and here it is, this is beta. This is a keto group because CO group attached to two other carbon atoms. So this is ester part, and this carbon is alpha and this carbon is beta. This is a beta keto. So this is beta keto ester. This type of reaction is known as claisen condensation. So claisen condensation. One more example let us discuss for claisen condensation. Look at here. Another ester I am taking having alpha hydrogen. So look at it here. CH3, CH2, CO, OCH3. Okay, this is first molecule. In this case, this is alpha hydrogen. So these hydrogen atoms are alpha hydrogen atoms. So how will you write the second molecule? Second molecule can be written as CH3. Here it is CH2, can be written as CHH. Then the rest is COOCH3. Correct? So what will be eliminated? CH3OH will be eliminated, and what we get? We get CH3. Here it is. You can take RONA, sodium alkoxide. Okay, CH3, CH2. Here it is CO, and here it is CH. Here it is CH3, and here it is COOCH3. Okay. This is also, this is alpha, beta keto ester. Okay, this reaction is known as claisen condensation. So that's all about esters. Next we are passing to ascent and descent in the carboxylic acid series. What is that? Ascent and descent in the carboxylic acid series. What do you mean by ascent and descent in the carboxylic acid series? Okay, let us come to the first point. Conversion of carboxylic acid to the next higher homologue. Next higher homologue in the series. Okay, this is the ascent. Okay, conversion of carboxylic acid to the next higher homologue. What do you mean by to the next higher homologue? That means we are starting with a carboxylic acid and we are ending with another carboxylic acid which containing one carbon additional or extra than in the starting carboxylic acid. So we get a carboxylic acid with one additional carbon than that in the starting carboxylic acid. This is what is called conversion of carboxylic acid to the next higher homologue. That is what is called ascent. Okay. So look at here, how do you convert a carboxylic acid to the next carboxylic acid? That means the next carboxylic acid containing one additional carbon atom. Look at here. We are starting with RCOH, okay, RCOH, and we are treating with thionyl chloride, SOCl2, thionyl chloride. First step, acid is treating with thionyl chloride. We get acid chloride, RCOCl, acid chloride. Okay. Now look at here. This acid chloride is treating with. We are treating with. First we get acid chloride, then this acid chloride treating with we studied that Rosenman reduction. That means reducing with hydrogen in presence of palladium and barium sulfate. We know that RCOCl will be converted to RCHO, aldehyde, RC double bond OH. Aldehyde we are getting, and in the next step what is happening, this aldehyde is reducing with lithium aluminium hydride LiAlH4. So aldehyde will be converted to alcohol, that means CO group will be converted to CH2OH. So what is that? CHO group will be converted to CH2OH. This also we have studied. Now in the next step, look at here, we are treating with this alcohol is treating with Br2 in presence of red phosphorus. Then OH group will be substituted with bromine. So what we get? We get RCH2Br, and in the next step, look at here, this RCH2Br is treating with KCN, potassium cyanide. Then we get RCH2CN, alkyl cyanide or alkane nitrile, and we know that cyanides, nitrile on hydrolysis will change into carboxylic acid. Okay, CN group will be converted to on hydrolysis H2OH plus CN group will be converted to COH group. So we get RCH2COOH. So we starting with RCOH and ending with RCH2COH. That means one extra carbon atom, additional carbon atom. So once again, so conversion of carboxylic acid to the next higher homologue. Okay, so starting with the RCOH, in the first step treating with the thionyl chloride, we get acid chloride RCOCl. Acid chloride on Rosenman reduction, acid chloride will be reduced to aldehyde RCHO. Then RCHO on reduction with the lithium aluminium hydride, we get primary alcohol RCH2OH. CHO group will be converted to CH2OH. Now this RCH2OH when treated with bromine in presence of red phosphorus, what is a nucleophilic substitution reaction? OH is replacing by Br. beer. So we get RCH2Br. Next, this one is treating with alkyl bromide is treating with the KCl. We get alkyl cyanide. Alkyl cyanide on hydrolysis will be converted to carboxylic acid, and that carboxylic acid is containing one carbon additional than in the starting carboxylic acid. So this is the ascent of carboxylic acid. Next is descent. So what is the next heading? B. Conversion of carboxylic acid to the next lower homologue in the series. That means we are starting with a carboxylic acid and ending with another carboxylic acid that contain one carbon less than that in the starting carboxylic acid. Okay, so that is what is called descent in the series. Descent in the series, one carbon is less than that in the starting carboxylic acid. So look at it here, RCH2COH. We are starting with this carboxylic acid. Now this carboxylic acid on treating with ammonia, heating with ammonia, what we will get? We will get amide. COH group will be converted to CONH2. So what we get? RCH2 CONH2. This we have studied. Okay, amide will be converted to amide. Now we know that this amide when treated with Br2 and Br2KOH, what is the name of this reaction? Hofmann bromamide reaction. Okay, this is Hofmann reaction, Hofmann bromamide or Hofmann degradation reaction. So what will happen? The CONH2 group will be converted to a primary amine. Amide will be converted to a primary amine with one carbon less than that in the starting amide. So what we get? RCH2CONH2 will be converted to RCH2NH2. This also we studied. Okay, Hofmann degradation. We get a primary amine with contain one carbon less than that in the amide. Now in the next step we can see that when this amine is treated with nitrous acid, that means HCl and sodium nitrite NaNO2. This also you have studied. Nitrous acid, what we get? We get disonium salt. When it is treated with amine, NH2 group is treated with nitrous acid. What we will get? We get N2Cl. So what we get? We get RCH2 N2 plus Cl minus disonium salt we are getting. This disonium salt on reaction with water H2O, what will happen? N2Cl will be converted to OH group. That also we studied. So what we get when it is treated with H2O, we get RCH2OH alcohol. We get alcohol. Now this alcohol on oxidation with KMnO4 on oxidation with KMnO4, alcohol on oxidation with KMnO4, what we get? We get carboxylic acid. If you are using a strong oxidizing agent, it will end up with the carboxylic acid. So what we get? First it will change into aldehyde, then it will be finally it will be converted to carboxylic acid, RCOH. So we are starting with the RCH2COH and ending with the RCOH. Okay, so once again I am repeating. First carboxylic acid is treating with ammonia. We get amide. This amide on Hofmann degradation reaction, we get amine, primary amine. On reaction with nitrous acid, we get disonium salt. Disonium salt on reaction with water, we get alcohol. Alcohol on oxidation, we get carboxylic acid. Okay.